Okay, section 3.3, function notation. In this lesson, we're going to use function notation to evaluate and interpret functions. We're going to use function notation to solve and graph functions. And then we're going to solve some real-life problems using function notation. Again, if we remember reviewing some vocabulary, the word function. Function is a relation with every input having exactly one output. Okay, so every input can have at most exactly one output. Okay, so when dealing with multiple functions, we know a linear function can be written in the form y equals mx plus b. So let's say y equals 2x plus 5. Another linear function, y equals 1/2 x minus 6. Okay, so if I asked you to, hey, put a 6 into that function, okay, you wouldn't really know which one I'm talking about. Okay, function notation allows us to talk more about functions and be able to tell them apart by giving them names. So instead of writing this function as y equals 2x plus 5, we would write it as f of x equals 2x plus 5. So this here, this bit here is how you say it is f of x. Okay. Okay, this is not a multiply. Okay, big caution here. This is not a multiply. Okay. What this is, this f of x, is telling me that this f is the name of the function. So the name of this function is f. That is his name. And this x here is just telling me what my independent variable is. Okay, so here we're using the letter f to name this function. You can use any letter you want. For some reason we tend to use f, I'm not quite sure. Okay, and so this function over here, we could, let's call him g of x equals 1/2 x minus 6. Okay. Again, this here would be, you'd say this as g of x. Again, g here is the name of that function. We're giving him a name. So now if I asked you, hey, I want you to put 6 into f. Okay, put 6 into f. Okay, I know which function you're talking about. I want you to put a 6 into this guy. And I can even shorten it up. Instead of me having to say, hey, put a 6 into f, I can write it this way, f of 6. That tells me that I want to put a 6 in for my x inside that f function. I want you to put it inside this f function. So I would have to take 2 times 6 and then add 5. 2 times 6 is 12, add 5 is 17. So we would say f of 6 is 17. So when I have, again, this 6 is my input, of 6, 17 here is my output. Okay, so a lot of times we'd write it this way, f of 6 equals 17. So this tells me my input's in there. That's my input. Let's go, there's my input. And this guy right here, that 17 is my output. So in this first example, if I want to evaluate, so here's my function. This is my function, f of x equals negative 4x plus 7. And I want to evaluate that when x equals 2. So I want to replace my x with 2. So I would write this as f of 2. Okay, I replaced that x there with a 2 equals negative 4 times 2 plus 7. Order of operations tells me I have to do the multiply first, negative 8 plus 7, which is negative 1. So I'd write f of 2 equals negative 1. So when my input was 2, there's my input. My output is negative 1. Okay. And then next one, it asks when x is negative 2. So we want to put this negative 2 in for x. So we'd go f of negative 2. Again, pay attention to how I'm saying that. That's f of negative 2. I have negative 4 times negative 2 plus 7. That would give me positive 8, which is 15. So we would say f of negative 2 is 15. So to write this as an ordered pair, I'd have the point negative 2, 15, because again, this there is my input. Okay. All right, so let's go ahead and let's do some function notation and see if we can't make some sense out of it. So here they say let f of t. So here's my name of my function, f of t. Again, knowing that this t is my input, my independent variable, be the outside temperature f. So f of t, this whole thing is the outside temp. T hours, T, my input, is the number of hours after 6 a.m. Explain the meaning of each sentence, of each statement. Okay, so, all right, first of all, so this is f of 0. So this is T, this is my time. And we know f of 0 is equal to 58, so this is my output. This would be my outside temp, my temperature. So this tells me at time 0, and this is T hours after 6 a.m. So 0 hours after 6 a.m. So that would be at 6 a.m. The temp, the temp is 58 degrees Fahrenheit. Okay, next one. So again, here's my input. That's my T. This is my output. That's my temp. Okay. Okay, so input 6 hours. So here we're at 6 hours after 6 a.m. Well, for 6 hours after 6 a.m., well, that would be 12 noon. At noon, the temp is, we just have a variable, n degrees Fahrenheit. We don't really have a number, so we'll just say n degrees Fahrenheit. At noon, the temp is n degrees Fahrenheit. Okay. All right, so here we have f of 3. Again, this symbol here is less than f of 9. Okay, well, what the heck do these mean? F of 3, this would mean, this is talking about the temp. This guy here is the temp 3 hours after 6. And this one here would be the temp 9 hours after 6 a.m. Okay, so this tells me the temp 3 hours after 6 a.m. is less than the temp 9 hours after 6 a.m. So 3 hours after 6 a.m., 6, 7, 8, 9. So we'd say the temp at 9 a.m. is less than what? The temp at, what would that be, 3 p.m. if we're 9 hours? So the temp at 9 a.m. is less than the temp at 3 p.m. Okay. So now I want you to pause the video and do page 125, 4 through 12 even. Please see me if you need help. Okay. All right, so now example 3. Okay, so here it says 4, so here's my function. h of x equals 2/3 x minus 5. We want to find the value of x. Find the value of x. So this tells me that our final answer is going to be an x equals something, for which h of x equals negative 7. H of x equals negative 7. Well, from over here, we know h of x is equal to this guy right here. So I'm going to replace this h of x with this guy right here. So then I'd end up h of x is that guy. So 2/3 x minus 5. We want to know, where does that equal negative 7? So now I have an equation to solve for x, because we want to find the value of x. Okay, so I'd have to add 5 to both sides. So 2/3 x equals negative 2. And then I could either divide both sides by 2/3. I think I'm going to multiply both sides by the reciprocal, 3/2, because I think multiplying by fractions is easier. Those two multiplied give me 1. I'd end up with 6 over 6, which is 1. So we have 1x equals, this is 2 over 1. If I multiply this across, I'd have negative 6 over 2, which is negative 3. X is negative 3. So I can check this one. If x is negative 3, if I put a negative 3 in here for x, h of negative 3, I should get out this 7. So h of negative 3. So 2/3 times negative 3 minus 5, 3 over 1. So 2/3 times negative 3, negative 6 over 3 minus 5, negative 2 minus 5. Yep, negative 7. Yep, it worked. So x is negative 3. All right, now pause the video again and do 14 through 22 even. Please do not submit your work until you have all the practice done. Okay. All right, now we have another example. We need to graph a function. Okay, so here we want a graph. We want a picture of this function right here. Okay, so the easiest way to come up with a picture of this is to come up with a table. Instead of x, y, because that's our y, we're going to do an x, f of x. And I'm just going to pick some points. Okay, pick some positive, pick some negative, kind of do a bit of, I'm going to do negative 2, 0, I don't know, 1, and 2. We'll see if that's enough to get a good idea on what this looks like. So when I put a negative 2 into this function, we'd have f of negative 2, 2 times negative 2 plus 5, gives me negative 4 plus 5, which is 1. So then I'd have the ordered pair negative 2, 1. Put in a 0, f of 0, negative 2, oh, it's positive 2. 2 times 0 plus 5, well, that's going to give me 5.05. Put in a 1, f of 1. 2 times 1 plus 5 is 7. Ordered pair 1, 7, and then put in a 2. 2 times 2 plus 5, that gives me 4 plus 5 is 9. Okay, so we're going to come over here, we're going to plot these points. We have the point negative 2, 1, negative 2, 1, 0, 1, 2, 3, 4, 5, 1, 5, 6, 7. Okay, I think I'm going to put in a negative 1 just to see what's happening back there, just because of how my graph is looking. Negative 1, f of negative 1, 2 times negative 1 plus 5. Negative 2 plus 5 is 3. Negative 1. Okay. All right, we get a general idea. Since this is not a discrete domain, they don't tell me the domain, so we assume it's all real numbers. I would go ahead and connect the dots, draw my line in. So that means any point on this line will work in that equation. So that point, that point, that point, that point will work in that guy there. All right, last example. Okay. So here we have, the graph shows the number of miles a helicopter is from its destination after X hours on its first flight. So let's go ahead, let's look at this graph just to make sure we understand. So here's hours. Here's the distance in miles. So here at 0 hours, it is 300 miles from its destination. After 1 hour, it's 200 miles. After 2 hours, it's 100 miles. After 3 hours, it's there. So that tells me here at 3 hours, it is there. Okay. On its second flight, the helicopter travels 50 miles farther and it increases its speed by 25 miles per hour. The function f of x equals 350 minus 125x represents the second flight. So they give me the equation. F of x equals 350 minus 125x. where X is the number of miles the helicopter is from its destination after X hours. Which flight takes less time? Well, we said in this one, you're at your destination after 3 hours. So we know for this flight, you're at your destination after 3 hours for this first flight. So now let's go ahead and let's look at this one. I think, again, I'm going to create an f of x table for this. And let's kind of do the same numbers. Here we did 0, 1, 2, 3. Let's do that. 0, 1, 2, 3, and kind of see what we get and go from there. So we want to go f of 0. So here we have 350 minus 125 times 0, which would be 350. Okay, 1. So 350 minus 125 times 1. So 350 minus 1. 350 minus 125 would be 225. 2 hours, f of 2. 350 minus 125 times 2. 125 times 2 is what, 250? So 350 minus 250 is 100. Okay, now 3 hours, f of 3, 350, 25 times 3. I don't know 125 times 3, so let's go ahead. Let's pull the calculator. So we'll go 350 minus 125 times 3, negative 25. Okay, I can tell right there that we went negative, that we are past our destination at that point. Okay, but let's go ahead, let's kind of get a graph on this. Here, this one counted by 50s. We can try doing that. 51, 152, 253, 350. So we'll kind of have to go off the graph a little bit here. So at 0, we're at 350. That's for this first ordered pair right here. 1 hour here, we would be at 225. So 50, we're counting by 50s. Let's mark it. 150, 2, 250, 3. Okay, so after 1 hour, we'd be up here at 225. So we go there. At 2 hours, we'd be at 100. At 3 hours, we're at negative 25. So like down here. Okay, so if we go ahead and connect the dots here, here at some point before 3 hours, because this is 3 hours right here, at some point before 3 hours, we reached 0, which means that we are 0 miles from our destination, which means we're at our destination. So here, this one happens just before 3 hours. So it says which flight takes less time? Well, that would be the second flight, the one with the faster speed. Okay, which makes sense that you increased your speed, but you also went farther. So here we started up here at 350. This one we only started at 300. So sometimes depending if it's farther. So which flight takes less time? Okay, the second flight, the return flight takes less time. It gets there in less than 3 hours. Okay. All right, the last bit of practice, this last bit, 125, 24 through 34. Once you get those all finished, please submit them to Schoology so you can correct your answers.